welcome to CEC lectures. Myself Dr. Preeti Dagwani from Department of Computer Science, Aribhat College, University of Delhi. So in this series of operating systems, today's topic is types of operating system. So we have in the previous lectures we have seen what is operating system, what all kind of services are provided by operating system. So now today we are going to see what all are the types of operating system. So basically, or we can say this is a kind of journey that is starting from the very first computer generation. Operating system kind of evolve themselves with the time. They continuously evolve themselves with the time. So what all kind of types are operating system with those evolvement, that is what we are going to see in today's lecture. So when we say types of operating system, so types of operating system starting from the earliest one, we have batch operating system, then we have time sharing operating system, distributed operating system, network operating system, and real-time operating system. Now the compartmentalization of these types is not very hard and fast. You may have some resources or you may have some material which give you one or two pluses or minuses types over here as well. Now with this note, let us begin with the batch operating system. So batch operating system, in the previous lecture I have told you that batch interfaces are there. So batch interfaces is basically what is being done here is users are not going to interact with the computer system directly, rather each user prepares his job on an any storage offline device, for example punch cards, and submit it to the computer operator. It is the computer operator who is going to deal with the computer system directly by preparing a batch of similar kind of jobs. Now why this batch is being prepared, the only agenda here is to speed up the processing. So jobs of similar kinds, jobs with the similar needs are batched together and run as a group. So basically what is being done here is programmers are going to leave their programs, leave their task with the operator, and operator after kind of sorting that programs into similar requirement batches will sort them, and then these similar requirement batches are to be executed simultaneously, I can say. Now this is one of the systems, or this is one of the operating system which was available or which was more into prevalence when with the earlier computer system, when these punched cards or magnetic tapes were used as the input output devices. Now but there are kind of, we can say, various issues along with this batch operating system. So the first issue comes under the way it is being operated is users are not interacting directly with the system. So there is a lack of interaction between the user and the job, and we always know that this mechanical input output devices, for example I am talking about a punch card, keeping this punch card into a reader machine, then reading these mechanical devices and then giving the process to the CPU is actually a slow process as compared to the time in which CPU is going to process. CPU is quite fast as compared to this whole process. So what is the disadvantage here in the batch processing is CPU is often sitting idle because of the speed mismatch between the CPU execution and the speed of mechanical input output devices. So CPU sitting idle is not considered as a kind of a good situation for a system. Also, when we are making batch of similar requirement jobs, it is difficult or it is quite of impossible to provide the desired priority. Also, if your user is not interacting directly with your computer system, if there are kind of some jobs which need interaction within the with the programmer or with the user even in between, so that that is not a kind of suitable scenario for the batch processing. So, batch processing says submit your job to the operator and then just wait for the output. If an interaction is required in between, batch processing operating system is not the ideal choice here. Coming to next, which we have seen already in detail, is time sharing operating system, and in the previous lectures I have told you this time sharing operating system is kind of a logical extension of multi-programmed operating system. So, let us try to recap this time sharing operating system, because this term still has a relevance here inside the topic of types of operating system. So, time sharing operating system enables many users. These users can be located at various terminals to use a particular computer system at the same time, simultaneously, I can say. So, time sharing, or we can say multitasking, as I have told you, is a logical extension of multi-programming, and the time of processor or the CPU cycles are being shared by multiple users, and this whole process is known as time sharing. So, which job is going to get the time of CPU, when it is going to get, and for how much time it is going to get, these are actually all policy decisions, and these are implemented with the help of operating system. Now, when we say that there is a difference between multi-programming operating system and time sharing operating system, or maybe multi-programmed batch system and time sharing operating system, the when we have a multi-programmed batch system, the whole agenda or the objective is to maximize processor use, whereas in the time sharing system the objective is to minimize the response time. Although they are closely connected to each other, the way in which they work, but there are different objectives for the for both of the system. So, here in time sharing operating systems, or in time sharing systems, I can say multiple jobs are executed by the CPU, and jobs are kept switching for CPU, or switching between them is happening for CPU, but the switches occur so frequently that each and every user or each and every job is having an impression that he or she or it is being attended solely. That means it is not, the time sharing operating system are so fast, or it happens, it is executed, or the switch is occurring so frequently and fast that the user is having a false impression that only my job is being attended completely and solely. And because these are kind of so frequent and fast, the user can receive an immediate response, I can say, and this immediate response is, or the for the time being for which the CPU is shared or CPU is allocated to one job, that is basically known as time quantum. So, time sharing operating system or time sharing systems and all those policy decisions which I was talking about will be seen in upcoming lectures. Then here, when we talk about a time quantum, so time quantum is something when the user submits the commands and response time is in the few seconds at most. So, each and every user of the time sharing system has to get some response within a specific time quantum. So, coming to the advantages of time sharing operating system is, one is the quick response time, and when we are talking about quick response time, that means your CPU is sitting idle for a lesser time or a reduced CPU idle time. That means, for example, there are kind of let us say 5-6 jobs which are competing or which are waiting for the CPU to be allocated. One is given, let us say job 1 is given CPU, and then meanwhile, for example, job 1 needs some input output. So, job 1 releases CPU, job 2 will take the CPU, and job 1 will move for the input output devices. Or maybe the situation could be job 1 is given a time quantum of CPU or a specific time of CPU. For that particular time, CPU is allocated to it. If its need is done, fine, otherwise it will again kind of come and join the queue in order to get some more CPU time. So that depends, but somehow, or with these policy decisions, time sharing operating systems provides you the advantage of a reduced CPU time, but there are as there are two sides of the coins, there is a disadvantage of the time sharing operating system is data communication is required, switching between the jobs is required, that's an kind of, I can say, additional headache. And also the question of security and integrity of the user programs and data, because all are working in a similar system, so they have to be compartmentalized in a hard manner so that no overlapping should go on. Also security and integrity of all user programs and data has to be managed, so an additional kind of a work is there. The third operating system, or the third type of the operating system which we are going to discuss here, is the distributed operating system. So till this point we have seen time sharing operating system and batch operating system. Now coming to distributed operating system, as the name indicates, distributed, that means it is going to use multiple processors in order to serve many applications. These applications may be real time, or these applications are real time, that's why the multiple processors are to be involved. So multiple processors are there to serve many real time applications of multiple users. Now these could be data processing jobs or CPU intensive jobs, or what all jobs it could be. So data processing jobs are distributed among the processors accordingly. There are multiple processors and jobs are distributed among them. The processor communicates with one another through various communication lines, for example high speed buses, and these processors can be part of a single computer or can be part of different computers, and these different computers are connected with the help of a network. And now as the processing power is distributed among the nodes, these are known as loosely coupled system or distributed system. So in order to manage this kind of a setting, we need a specific kind of operating system, and that operating system is known as distributed operating system. To add more to its agony, I can say processors in a distributed system may vary in size and functions, and these processors which are kind of maybe on the different locations are referred as sites, nodes, computers and so on, but they have kind of different functionalities, different size, different processing powers could be there. Now with this distributed, with this non-centralized kind of system, we have many advantages. Because the system is non-centralized, there is a resource sharing facility which enables a user at a particular site or at a particular node to use the resources available at another node. Now let us say there are some 4 or 5 sites, and if one site fails in a distributed system, then the remaining sites can potentially continue operating, and then they may take over the work of the site which is down, if it is possible, in order to ensure the promised response time, I can say. So overall it is providing some better services to the customer. Then there is no centralized system, so basically reduction of the load on the host computer is automatically there. There is no load on the host computer, there are multiple processors serving multiple users. So delays in data processing are obviously is one thing which are being reduced. So if someone wants to, or some kind of scenario or application wanted this distributed operating system along with the many advantages which we have seen, now we have some management issues as well. But this whole system needs a separate needs a different kind of operating system in order to manage this whole thing, in order to manage the whole nuances. So that is known as distributed operating system. Now coming to another type, which is network operating system. Now coming to the network operating system, first try to see quickly that what actually this network is. So in case of a client server network, I can say there is a server, there is a main computer which is serving the other computers which are client. Now, do we need a different kind of operating system for to be loaded on this server? Yes, because this is not a normal computer. It is giving service to the other clients, I can say, or to the other computers. So we need a separate operating system which is known as a network operating system, and network operating system is capable of running on a server and provides the server the capability to manage the data, to manage the user groups, security, application and other networking functions. So if we go into details of some networking fundamentals, we can say there are many functions of a network: to share the data, to maintain the security, to share the application load, and so on and so forth. All those networking functions are to be, I can say, managed by the operating system which is running on the server. The primary purpose of the network operating system is to have a shared environment, a shared, era, we can say, in which a file is allowed to be shared, a printer is allowed to be shared along the multiple computers in a network. And this was a very common scenario in the earlier, office setups, that they do have a, huge printer which is being shared by many of the computers or many of the users, and this is done through a typical private network or maybe a local area network. What all is available, that depends. So coming to, when we talk about network operating system, there are many examples to these network operating system. One is Microsoft Windows Server 2003, then the upgraded versions Microsoft Windows Server 2008, Unix and Linux, also Mac OS X, Novel NetWare and BSD operating system. All these are the examples of network operating system. Now, what are the, coming to the characteristics, which are the advantages of this operating system, is your centralized server, because of their huge processing and other capabilities, these are highly stable. Security is managed by the server, so client is not worried about the security. Then any upgrade to new technologies or any upgrade to the hardware is easily integrated into the system, because only the server is to be upgraded, and from different locations and types of the system, remote access to the server is also possible. But along with the advantages, if we are managing this whole ramp show of having a server which is capable of managing all the network functions and all kinds of securities being provided to clients and many other facilities as well of sharing the resources, there comes the disadvantages with this operating system. So these are very obvious disadvantages, which include high cost of buying and maintaining and running a server. Another, although servers are very reliable, but they may go, they may crash or something of that sort. So what happens if a server is down? That means your whole network is not going to work for some particular time till which your service is down. So what I am trying to say is there is a dependency on the central location for most of the operations, and if that server is down, the client is not able to do much without it. Then it is not only a purchasing and running a server, the regular maintenance and updates are also required to be installed onto the server. So till this point we have seen batch operating system, which was most prevalent with the earlier operating systems. Then we have time sharing operating systems, which was a logical extension of your multi-programming operating system and time sharing operating system. You can call it as multitasking as well, and how it is being done, that also we have seen. Then we have seen one very powerful operating system, which is distributed operating system, and it is able to kind of manage many sites at a time. And then later on we have seen network operating system just now, along with its advantages and disadvantages. Now coming to the next type, which is real time operating system. So when we talk about real time system, so let me give you an example of a real time system. For example, there is a rocket launcher system. So rocket has to be launched in a very specific and precise time. So that's a real time operating system. Or even a door which is opening and shutting with the sensor, and it is sensing the presence of a human getting in or going out. That you can say is also a real time operating system. Or maybe a robot is opening a door by sensing the presence of some human being or someone entering into the system. So that's also a real time operating system. Basically, from operating system point of view, if we can see, it is a data processing system in which the time interval required to process and respond to the inputs is very stringent, very tight, and it is so small that it controls the environment. If that small input time is not met, then there is no point in having that data processing system as real time operating system. So basically what I am trying to say here is the time taken by the system to respond to an input and display the required updated information, that is basically the response time. So response time here is very less as compared to the normal processing systems. The whole show of real time operating system is based on the response time, which is going to be very less, very precise, and very accurate. Your system should not fail in terms of response time. So for example, before launching a rocket, I need to calculate some weather parameters. Now what if these weather parameters are not reported on a particular point of time and rocket is being launched, and then it may create a mess. So the response time has to be very tight, stringent, or less. I can say a very quick response time, or a response time in this response in a real time is required. Now what actually this response is, the time or response time is the time taken by the system to respond to an input and display of required updated information. So your real time operating systems are the systems which are used in rigid time requirements on the operation of a processor or the flow of data. There is strict timing control. So in order to ensure that a real time operating system must have a fixed time constraint, a well defined time constraint, otherwise our system is going to create a mess, as I have given an example. So for example, not only the rocket launching, but any scientific experiment for that matter, any medical imaging system, any industrial control system, weapon system, or the systems in army, or even your ATC system, which is the air traffic control system, are the example of real time systems. And the operating systems which are there to control or to implement these systems are known as real time operating system. Now talking about real time operating systems, there are basically two types of this. One is a hard real time system, another one is a soft real time systems. So as the name indicates, soft real time system. So soft real time system here means this guarantee that critical tasks are completed on the time, and because it is about submissions of input and output in a very quick manner, secondary storage could be limited or missing and the data is stored in ROM because of the fast access, we can say. Another type of real time systems is the soft real time systems. As they are soft, they are restrictive, and a critical real time task gets priority over the other task, even if it is in the soft real time systems. If it is a critical real time task, it is obviously going to get the priority over the other task and retain that priority until that it completes. It is having this whole system of soft real time system is having limited utility than hard real time systems, because if we are talking about real time systems, then it has to be very, very stringent and strict in terms of response time at least. But yes, there are some examples of soft real time systems as well, like your virtual reality or advanced scientific projects like undersea exploration and planetary rovers, etc. So soft real time or kind of a less restrictive response time will do here. But in case of those scientific experiments, for example rocket launching, it has to be very, very critically strict response time system. So in this lecture, what we have seen, let's summarize the lecture. We have started with what are the types of operating system, and we have seen batch operating system. Then we have time sharing operating system. Apart from that, we have seen distributed operating system, network operating system, and also the real time system. Here is a list of references used for preparation of this lecture. Hope you enjoyed the lecture. Thank you for your patience.